So now, welcome to all in my channel Isan Study Ada. Today we are going to discuss about the most important chapter of chemistry, that is thermodynamics. So let's start our chapter thermodynamics. So now we understand the what is the need of thermodynamics and how the thermodynamics can be studied, types, modes, segments. So now we're going to study before studying thermodynamics. We're going to understand its relevance and its meaning. So this is our chapter thermodynamics. So now, for now, we understand the meaning of it. Thermo and dynamics. Thermo, it is related to the heat, and dynamics related to the motion, or we can say movement. Suppose anything which is in motion or movement, we termed as dynamic. That means the thing is dynamic in nature, which move or having motion. So, and what is the meaning of thermo? So, thermo means heat. So, what we study here, study here the movement, how movement is done. If we know heat is a form of energy, so it is transferred. So, movement or transfer of heat, transfer of heat energy, transfer of heat energy, we can say we study in the thermodynamics. Transfer of heat energy we study in the thermodynamics. Everything is around the heat energy, or we can say heat. So let's, without wasting our time, we discuss about thermodynamics. So what are the pointers we have to discuss in thermodynamics? So studied, first we have studied about the definition of thermodynamics. Definition of thermodynamics. Second, we're going to study about the system surrounding. What is system surrounding? Third, we're going to study about the our types of process, system and surrounding types of process. Fourth, we study about types of properties. How many types of properties we have to study here. After that, we study modes of heat transfer, modes of heat, or we can say modes of energy transfer, mode of energy transfer. In how many modes energy got transferred? Let us rub this heat, mode of energy transfer. We study here. So without wasting our time, we now discuss what is. We have already studied definition of thermodynamics. Thermodynamics deals with the heat energy, transfer of heat energy, or we can say change in a heat energy, or we can say change in a energy we can studied under the thermodynamics. Here we can't study about the total energy. We study about the change in a energy or change in the heat energy of the system is termed as thermodynamics. I have here used the word system. So now let's break the terms. First term is our system, and our second term is surrounding. First term is our system and second term is our surrounding. So what is the meaning of system and surrounding. So what is system? Simply we can understand anything which is under the investigation. Anything under investigation. Anything which is under investigation is termed as the system. So what is surrounding? Rest of the things. Rest of the things excluding system. Excluding system. The rest of the things after excluding system is termed as the surrounding. How can we differentiate between system and surrounding? So there is a line of separation, or there is a wall between system and surrounding which we help to understand, that is termed as the boundary. We termed as it as boundary. So boundary, it might be real or imaginary. Boundary must be real or imaginary. Sometimes we assume and sometimes we get the real boundary. So which separates the system and surrounding is termed as the boundary. Anything which is under investigation is termed as the system, and except anything except the system is termed as the surrounding. Now we're going to study by the help of one single example. So what is example? Suppose I'm talking about the jar. There is a one jar. This jar contains full of gas. This jar contains gases. Now, how can we identify which is system here? Suppose we have written a one statement: pressure of a gas of 1 mole is 1 atmospheric pressure. So, how can we identify system and surroundings? So, we have discussed about the pressure of what? Gas. So, what is under investigation here? Gas or molecules of gas. So, gaseous molecules here termed as the system, and the rest of thing around this gas molecule. Rest of thing around the gas molecule is termed as surrounding. Or we can say this is the system and everything around it is termed as surrounding. Everything around is termed as surrounding. So there is a line, one thin line, that is termed as boundary for the separation of system and surrounding. These boundaries of two types. First is conductor boundary and second is insulator boundary. We all know about the meaning of conductor and insulator here. Conductor means in which heat is exchanged from system and surrounding, or we can say heat is exchanged between system and surrounding is termed as the conductor boundary. Insulator boundary, in which heat cannot be exchanged or energy cannot be exchanged between system and surrounding. So for conductor boundary, we having the example of water bottle. Water bottle, in which we can see the temperature rise. In insulator, we talk about the thermoflask. Thermoflask, we have an insulation. If we suppose we have example thermoflask having the cotton insulation in it for the heat cannot be transmitted from the thermos flask, so that we get the, if we put a hot water in, it remains hot. If we put a cold water in, it remains cold. Now we study about we have understand what is the system and what is the surrounding. So next example is for understanding the system and surrounding. Suppose this is my cheek, or we can say gall. मैंने इसका पहले टेम्परेचर चेक किया. फर्स्टली आई चेक माई टेम्परेचर ऑफ माई चीक्स. It is around 10 degree and I put a one slap on it. After that its temperature goes up to 12 degrees Celsius. So here we can say or can we differentiate which is system and which is surrounding. My cheeks, whose temperature has been checked, is termed as system because it is under investigation by the property of temperature. We are measuring the temperature here. Temperature is in under investigation and everything around it is termed as surrounding. Now we going to our next part. I hope you understand what is the meaning of system and surrounding. Now we're going to discuss another part that is terms and types of system. Now we're going to study types of system. So here we can study types of system. There are three types of system. Types of system. For studying types of system, we need to understand the two terms which we use. First is energy, or second we use mass. We can differentiate systems on the basis of energy and mass. So now we're going to study first system, that is open system. What is open system? A system, a system in which energy and mass both are exchanged between system and surrounding. Energy and mass both are exchanged. Both are exchanged between system and surrounding. The open system in which heat and energy both are exchanged between system and surrounding. Now our second is closed system. What is closed system? So the system in which only in which only energy in which only energy is exchanged. In which only energy is exchanged between system and surrounding. Only energy exchange between system and surrounding. What means? It means there is no exchange of mass. Mass not exchange. मास का exchange नहीं होगा. Now we have studied about the third system, that is isolated. Isolated system. Isolated means it's like one person who is alone, neither talking to anyone, neither exchange their view. So similarly, like that, we can say isolated system is that in which neither energy nor mass is exchanged. Neither energy nor mass is exchanged. That system called isolated system. Now we have understand about the definition. Now, how can we understand by using the live examples or practical life examples? So now here we discuss about all the three systems. One is open system, second is our closed system, and third one is our isolated system. Isolated system. So example of open system, energy, mass both are exchanged. First example is boiling of water. Boiling of water. How? Suppose we have put some water on the flame. It is the flame, we have put some water on the flame. After some time, see that we have given putting on the flame, that means we providing some temperature. After getting temperature, before putting out into the flame, it is cold in nature. Water is cold in nature. After putting on the flame, water slowly got heated up. So we can say there is a exchange of heat or energy. Here we can say there is a exchange of heat or energy. Because in lower class, what we have understand the energy or heat is transferred from higher to lower, higher level to a lower level. After that, how can we say that mass is exchanged between system and surrounding? This a whole is surrounding. This is the system. This is the system. Everything around it is surrounding. So how mass is exchanged? When we boil some water, the we have understand or we have studied in earlier classes that evaporation process takes place. In evaporation, we know water amount got lessen up. That means suppose we have put 1 liter water to get boiled. After some time, we say there is some water get evaporated and it remains only 0.8 liter. 200 ml water gets evaporated in the surrounding in the form of water vapor. So we can say that it is an example of open system. Whose example is this? It is an example of open system. Now, second example that is making of, everyone know Indians are lover of chai or we can say tea. Making of tea. What we have seen if we want to make a tea for a two persons, we have to add at least 2.5 cup mixture of water and milk. So, suppose we have to make tea. We have added here, we have make a tea for a two person. So how much we have to add? We know chai get less enough when we put it for a more time. So we need to add 2.5 cup of milk plus water to form a tea so that we after making the tea or chai at least we get 2.1, suppose it's a 2.5 liter cup of milk plus water. So after that boiling of chai, we can get 2.1 liter and two-person easily drink the tea. Not possible to get the liters chai. I have just uses the example. Don't mind it. मतलब दिमाग को जोर देने की जरूरत नहीं है. ये सिर्फ एक तरह का एग्जाम्पल है. Now we are talking about the closed system. How can we case it on as if only energy is changed, mass is not exchanged? Suppose we are talking about the water bottle. Everyone knows water bottle. We go into the school by using the water bottles, or we can take up water bottle with us in the school. So in summertime, our water bottle is totally filled with cold water. Our water bottle is totally filled with cold water, having the cap on it. That means it is tightly closed. Suppose it is tightly closed, the water never comes out of the bottle. So there is no exchange of mass, no any other further process taken place. But how energy changes? Suppose if we put a water bottle for more than 6 hours in a summer time in the school, water gradually or we can slowly gets heated up. The cold water changes into a slightly warm water, slightly warm water. So we can say energy transferred from the higher to lower concentration, heat energy transfer from the surrounding to system. So water bottle is our system. So there is a transfer of heat energy only. So we can say in closed system only energy would exchange, mass never exchange in the closed system. Now we talk about the isolated system. Very well defined example of the isolated system, that is thermos. Well defined example of isolated system, that is thermos. If we talk about the thermos, everyone knows that if we put hot water in it, it remains hot for a day. If we put it cold water in it, it remains cold for a day. Thermoflask with stopper, tightly placed stopper, tightly placed stopper. So there is neither exchange of mass nor exchange of energy. So we have studied about the three systems. First is ice open system, second is closed system, and third is our isolated system by the help of the example. Now we going to study about we have studied the systems. What we study? How energy transferred, way of transfer of energy. So we talk about the modes of energy transfer. What are the modes of energy transfer? So there are the two modes of energy system. Suppose this is the system and everything around this is a surrounding. It is surrounding. So how energy transferred? This is E1 and this is E2. Energy 1 and energy 2. How energy transferred? Because energy is so much lazy. Energy cannot be transferred by itself. It needs some carrier to transfer it. Then how energy transferred? So energy transferred or modes of transfer of energy are two. First, in the form of Q, that is heat, and second, in the form of W, that is work. So we can say heat energy transferred in the two form. First is heat and second is work. There are two modes of transfer of energy, work and heat. If we talk about the heat transferred due to difference in their temperature, difference in their temperature. How? So how energy transferred? In the modes of energy transferred in the form of heat. When energy transferred in the form of heat, when there is a difference in their temperature. One is at higher temperature, another is lower temperature. So there is a flow of heat between high temperature to low temperature. Now in the form of work, so heat transferred in the form of work by when having the difference in their kinetic energy. Difference in their kinetic energy, the energy transferred in the form of work, because in kinetic energy we have done some more movement. As we know, kinetic energy is the energy of motion or movement. When motion is done in anything, the work has been done. So when difference in their kinetic energy, the energy transferred in the form of work. When difference in their temperature, energy transferred in the heat. Now after the modes of energy transfer, next we have to discuss the what is process. Before process, what we study first? First we study types of properties, not process. First we study types of properties. Types of properties. So here we have to study two types of properties. What are they? First is intensive property. First is intensive property. This first is intensive property, and second is extensive property. We have to deal only in the two properties. First is intensive and second is, if we talk about the bookish language, book says that the intensive properties are those properties which does not dependent or depend on size and amount of matter contained in amount or size of matter contained in. That means it does not depends on the mass. Next is extensive property. Opposite of it depends on the size and amount of matter contained in it. Amount of matter contained in it. Size and the amount of matter contained in it. So it is that means it is mass dependent and it is mass independent or independent, mass independent. Now we by understand there is the bookish language, but how can we differentiate? So we use this simple approach. Suppose we having the one box. If we divide it into two parts, it changes into two separate boxes. It changes into two separate boxes. Suppose mass get divided. So they divided into two parts. If there is no having any change due to the mass division, यदि मास के डिवाइड होने से इनमें कोई भी चेंज नहीं आ रहा है, then we can say that they are must have intensive, they are having the intensive property. Or if they show any change in their mass, if they show any change in their property by the division of mass, then we can say that it is extensive property. यदि मास में कोई चेंज आ रहा है प्रॉपर्टी डिवीजन से, ये सॉरी मास को डिवाइड करने से कोई भी प्रॉपर्टी में चेंज आ रहा है तो उसको हम एक्सटेंसिव प्रॉपर्टी बोलेंगे। यदि मास को डिवाइड करने से प्रॉपर्टी में कोई भी चेंज नहीं आ रहा है तो उसको हम इंटेंसिव बोलेंगे। कैसे? सपोज देयर इज अ वन पेन, आई हैविंग दी वन पेन, I have divided it into two parts. So we can say mass got half, mass got half. We have the full pen, we have divided into two parts, mass got half. That means his mass got changed. Suppose they having the pen of 4 gram. Now mass gets divided, so both are of getting 200 grams and 200 grams. The pen would be divided into two parts, 200, 200 grams. That means mass got half, mass got half. So there is a change in property due to the mass division. So we can say mass is our extensive property. Mass is our extensive property. Now we talk about the another example. Suppose we say that the temperature of this pen is 10 degrees Celsius. Suppose we can say the temperature of this whole pan is 10 degrees Celsius. Now we have divided the pan into two parts. So is there any difference in their temperature or temperature also got divided? No. If we talk about the two separate parts, suppose first part is this and second part is this. So both we are having temperature of 10 degrees Celsius and 10 degrees Celsius. Mass having 200 gram and mass having 200 grams. So what we concluded? We concluded here temperature is mass independent. That means or amount of matter or size of matter. If we divide it into two, three, four, five parts, temperature always remains same. So the property which does not depend on the division of mass, amount of matter content is termed as the intensive property. It is termed as the intensive property. Now we take one more example. Suppose we have taken one bottle. We have taken one bottle. We have divided it into two parts. We have divided into two parts. Now we can say area got half. एरिया गॉट एरिया आधा हो गया. सपोज इसका एरिया पहले कितना था. हाउ मच एरिया दे हैविंग. सपोज इट इज 20 meter square. Now area is divided into two parts. One is 10 meter square, another is 10 meter square. So area is mass dependent. Yes, area is mass dependent because area got half when we split anything into two halves. So what if we talk about area? Area is a extensive property. What is area is our extensive property. Now we talk about next. Suppose we talk about the pressure. If we put a pressure of 1 atmospheric pressure on this pan, that is the pressure of atmosphere. Surrounding atmospheric pressure is there 1 atmosphere. So we put it on it, or we can get a pressure of 1 atm. Then if we divide it into two parts, it could be possible that the pressure got half. No, the pressure on both the parts is remain same. That means in both part also 1 atmospheric pressure and 1 atmospheric pressure is done, or gets the two parts of the bottle also get the same pressure, 1 atmospheric pressure on the one part and one. So here we conclude that pressure is our intensive property. Pressure is what? Pressure is our intensive property. Now we conclude how many are known our extensive property and intensive property. Here make a table of extensive property and another is our intensive property. It is a very important table. That's why I'm giving you this table. One is intensive property, another is extensive property. So what is intensive and what is extensive? We have already studied. Now we property first. First is mass, extensive, volume, area, mass, volume, area. Next is mass, volume, area, enthalpy. Our is enthalpy, entropy. After that, gives free energy, internal energy, internal energy, gives free energy, internal energy, moles. These are the extensive property which are important to us. Now we talk about intensive property, temperature, pressure, temperature, pressure, internal energy per mole, internal energy per mole. This is the start mark. I tell you how. Internal energy per mole. After that, our boiling point, freezing point, vaporization point, melting point, atomic mass, molecular mass, molecular mass. These are the marked. I tell you how. Molecular mass. Because we have studied mass is a extensive property. How atomic mass and molecular mass is a intensive property. temperature, pressure. So, and next is our intensive property. So here is a list of intensive property. Further, we divide this do or the specific heat capacity, specific heat capacity. It is also a intensive property. So now we have discussed about these intensive and extensive property little amount. Further, we discuss more. After that, if we talk about restriction, there is a one ratio which we use in the ratio of the two extensive property. Ratio of the two extensive property is always become intensive property. Ratio of the two extensive property always become intensive property. So internal energy is extensive property. Internal energy is extensive property, and mole is also a extensive property. So ratio of both, it becomes internal energy per mole. So internal energy per mole becomes intensive property. About atomic mass, so we have already known mass क्या होगा ये, how it is, it is about mole by mass. Atomic mass is here, atomic mass is mass by mole. Mass by mole, here also mass by mole. So mole is also extensive property and mass is also extensive property. Mass is also extensive property, mole is also extensive property. Therefore, atomic mass and molecular mass is also a intensive property. These are the some important property we have discussed. Further, we also discuss if required. Now we are going to study the next part, that is our types of process. Types of process. So here we have to understand about the types of process. First is our isothermal. Isothermal process. So what is isothermal process? A process in which temperature remains constant. A process in which temperature remains constant. Therefore, process that is T equal to constant. When T is equal to constant, then differentiation of temperature is always zero. So the process in which temperature remains constant and dT becomes zero, the process is known as the isothermal process. Second process is isochoric process. So what is isochoric process? The isochoric process, the process in which volume remain constant. Volume remains constant throughout the process. The process known as the isochoric process. V is constant, then differentiation of V, that is dV is zero. After that, if we talk about the third process, that is isobaric process. So if we talk about the isobaric process, the process in which pressure remains constant. Pressure remains constant, that is P constant, then differentiation of P is always zero. This process is known as the isobaric process. Fourth is our adiabatic process. Adiabatic process. So what is adiabatic process? So the adiabatic process is in which heat exchange not taken place. That means there is no exchange of heat between system and surroundings in the process. It's known as the adiabatic process, and it is that means Q is constant. Q is constant, then dQ is zero. When Q is constant, dQ is zero. And here Q and dQ represents the same. Q and dQ represents the same. How Q and dq represent the same? Sorry, there is no exchange of heat, so the value of heat becomes zero, not constant. It is zero. When there is no exchange of heat, it is zero. Then dq also zero. So we can say that there is no change between q and dq. Both represent the change in heat. In adiabatic process, both represent the change in. Fifth process is our cyclic process. Cyclic process. What is cyclic process? There is no change in the state. No change in the state. No आएगा. No change in state. When there is no change in the state during the process, it termed as the cyclic process. Suppose we move from point A, B, C, D, and E. Suppose we start from the point A. We go to point B. From point B, we go to C. From C, we go to D, D to E, and E to further comes to A. So after completing one cycle, we come to A. Suppose A having the solid. After that, we reach to solid. That means there is no change of state from initial state to final state. Initial to final state. There is no change of state. During the initial or final, there is no change of state. Initial to final. Initial to final. There is no change of state. The process known as the cyclic process, in which we have to remember delta E and delta U is equal to 0. What is delta E and delta U? So either you learn as delta E and delta U, both meaning internal energy. Both represent internal energy. Either you talk about delta E or you talk about delta U. Both represent internal energy. In cyclic process, internal energy always remains zero, or change in internal energy always remains zero. So we have discussed about the types of process, modes of process, of transfer of energy, types. Now, what we have to study now? So we have to study what is types of function. Now we're going to study types of function. Today, this is the last topic, types of function. So there are two types of function. First is state function. First function is our state function, and second is our path function. First is our state function, second is our path function. What is state function? So if we talk about the state function, if we talk about the state function, it depends only on the initial and final. It depends on the initial and final state. It is a state function. It depends only on the initial and final state. It does not rely on the path which you follow. Suppose one is go from A to C directly, and one is go from A to B, then B to C. So if we go from A to C, or B go from A to B and B to C, the result would be the same. Result में कोई भी change नहीं आएगा. So we can say that any number of steps, any number of steps we use, results remains same. कितने भी step use करें, result same ही आएगा. Suppose A to C आने में result हमारा टेम्परेचर कम, सपोज A to C आने में हमारा जो टेम्परेचर था वो A to C आने में जो हमारा रिजल्ट था वो सिमिलर था। फिर हम चाहे A2, सपोज ये डेल्टा ई है, ये डेल्टा E1 है और ये डेल्टा E2 है। तो दो प्रोसेस, तो ये किसके बराबर होगा, तो डेल्टा ई ऑलवेज इक्वल टू डेल्टा E1 प्लस डेल्टा E2। अब that means either you follow the single path or you follow the several steps. It only depends on the initial and final state. So there is no change of result. Either you follow the five steps or you have completed in one step. What is the path function? It is opposite of it. It depends on the path or passage or steps you follow. It depends on the path, passage, and steps you follow. So next is in the path function, different steps results in different output. Different steps result in different output. We can't get the same output like the state function. Only four path function we have to remember. First is heat, second is work, third is heat capacity, and fourth is distance. These are only the four which are the path function. And remember one thing, for your remembrance, we do remember. There is a one star point. Heat and work, neither intensive nor extensive. Heat and work, neither intensive nor extensive. They are boundary properties. They are boundary properties. Now we discuss the last part, that is a modes of process. How the process. Okay. There are two modes of process. First is reversible and second is reversible and second is reversible. It is a natural process, real process, completed in finite time, require finite steps, P external is constant, outer pressure is constant here, and it is directional, occurs in single direction. Reversible, hypothetical, imaginary process, infinite time, infinite steps, all time balance, bidirectional, P external, variable in reversible. So how can we understand what is reversible? So everything which we see which is complete in a day, month, or a year is termed as the irreversible process. Suppose we put a button. it requires a day to get warm. So it is an irreversible process, or we can say natural process. The process which we able to see in our life, which we able to conclude in our life, और जब तक हम हैं तब तक हमें उसके रिजल्ट मिल रहे हैं, उस हम इरिवर्सिबल बोलेंगे, दैट मीन्स वो रिवर्स नहीं हो सकती. What we talk about the irreversible process, so irreversible process is this. What our reversible process, the process sun's energy never ending. So we can conclude it that the how in how much time the sun energy get deteriorated or get destructed. So it is an imaginary process for us because after taking several years of birth, even though we can't conclude the sun's age or sun's energy destruction. If we talk about the weather, we can't know how much time weather survive, how much time Earth will survive, because it is an imaginary process for us. हमको जानकारी नहीं है हम कब तक, जब तक हम है तब तक वो प्रोसेस कब भी एंड नहीं हो रही है, तो वो प्रोसेस हमारे लिए इमेजिनरी है. कितना समय लगेगा, कितने स्टेप लगेंगे, वो हमको नहीं पता. दैट मीन्स वी डोंट नो about these process, the process which not concluded by us or which remain imaginary from our side, which can't be realistic for us. Because it is not completed during our life duration, the process termed as the reversible process. And the reversible process, which is having the finite step, which we concluded, which we having the result, we termed as the natural process or real process. For today, now we have discussed a lot about the modes or type of process. So we conclude our chapter now. Thanks for watching. Ishan Sharma signing off. Thanks. I hope you like the lecture. Please continue.